Have you ever wondered how a Tesla coil can create a spectacular display of lightning in an ionosphere? This intricate dance of light and energy is more than just a stunning visual spectacle. It's a testament to the boundless potential of electricity and the human ingenuity that harnessed it. The enigma of electricity has captivated inquisitive minds for centuries, sparking a relentless quest for knowledge that has illuminated our world in more ways than one. Among the pantheon of pioneers who dared to delve into this enigma, one name stands out: Nikola Tesla, a man whose brilliant mind was light years ahead of his time. His creation, the Tesla coil, is a testament to the sheer power of human curiosity and innovation. Coupled with an ionosphere, it transforms into a dazzling display of electrical wizardry. So, buckle up as we unravel the science behind the Tesla coil and the ionosphere. Prepare to embark on a journey into the heart of electricity's most captivating mystery. Imagine a device that can produce high voltage, low current, high frequency, alternating current electricity. That's the Tesla coil for you. In the simplest terms, the Tesla coil is an electrical resonant transformer circuit. It's a bit of a mouthful, but it's not as complex as it sounds. Picture it like a slinky with electricity bouncing back and forth between 2 points, creating an electrical vibration. This vibration is what we call a resonant circuit. The genius behind this invention is none other than Nikola Tesla, a Serbian-American inventor, electrical engineer, mechanical engineer, and futurist. Tesla was a man ahead of his time, creating the Tesla coil back in the late 19th century, around 1891. His work laid the foundation for modern alternating currents, continue to inspire scientists and engineers even today. So, what exactly does a Tesla coil look like and how does it function? Well, a Tesla coil consists of two parts, a primary coil and secondary coil, each with its own capacitor. Capacitors, in layman's terms, are like small energy storage units. The primary coil pushes electricity into the secondary coil, which then amplifies this electricity and shoots it out into the air. Imagine it like a game of catch, but with electric energy instead of a ball. It's this ability to produce high-frequency alternating currents that sets the Tesla coil apart. Because of this high frequency, the energy produced by the Tesla coil can actually ionize air molecules, creating a spectacular light show. It's like a miniature lightning storm that we can create and control. Beyond its impressive light show, the Tesla coil has practical applications as well. It's used in radios, televisions, and other electronics to help amplify electrical signals, but perhaps most intriguing of all is its potential to transmit electricity wirelessly. Yes, you heard that right, wireless electricity. With this understanding, we can now explore how the Tesla coil interacts with the ionosphere. When electricity meets gas under controlled conditions, it gives birth to a luminous sphere of wonder, the ionosphere. This is not a scene from a science fiction movie, but a real-life spectacle that unfolds when science takes the reins. Simply put, an ionosphere is a ball of glowing gas, a marvel that is born out of the marriage between electricity and gas. How does this happen? Well, when an electric current is passed through a gas, the gas atoms get excited. Just like how a child would jump around in joy when given a sweet treat, these atoms too start moving around in a frenzy. As they move, they collide with each other, causing the release of energy in the form of light. This is the same principle that makes neon lights glow. Now, you may wonder, why is it called an ionosphere? The answer lies in what happens when the gas atoms get excited. As they move around, some of them lose electrons, turning into ions. The process is called ionization. And since these ions are confined to a sphere of gas, we call it an ionosphere. But the story of the ionosphere doesn't end here. It gets even more fascinating when it comes in contact with electric fields. Imagine a group of dancers swaying to the rhythm of music. Similarly, the ions in the sphere move in response to the electric field, creating a stunning light show. The ionosphere is not just a spectacle though, It holds immense potential in various fields of science, from plasma research to the study of electric fields. And guess what? The Tesla coil plays a significant role in creating these ionospheres. The high-frequency alternating currents produced by the Tesla coil can ionize gas, leading to the formation of these glowing spheres. This is the beauty of science. It can turn ordinary elements like gas and electricity into an extraordinary spectacle like the ionosphere. Now that we've understood the individual components, let's see them in action together. The magic truly begins when the Tesla coil. A Tesla coil, a high-frequency transformer pulsating with electric energy and an ion. When these two entities meet, something extraordinary happens. The high-frequency ray of light. It's a spectacle that's nothing short of mesmerizing. But what exactly is going on here? How does this interaction between the Tesla coil and the ionosphere work? Well, let's delve into that. The Tesla coil, as we know, is a resonant transformer circuit and high-frequency alternating current electricity. It's named after its inventor, Nikola Tesla, who patented the device in the late 19th century. The coil generates a significant amount of voltage, and when this voltage is high enough, it can ionize the air around it, creating a pathway for the electricity to travel. A phenomenon we often see as a spark or a bolt of lightning. On the other hand, the ionosphere, also known as a plasma globe, is a sealed glass globe filled with a mixture of various noble gases. When the Tesla coil's high-frequency currents are introduced, the gases in the sphere become ionized. This ionization process excites the electrons in the gas atoms, causing them to move to a higher energy state. When these excited electrons return to their normal state, they release energy in the form of light. This is what creates the stunning light show inside the ionosphere. But this isn't just a visually appealing science experiment. The interaction between the Tesla coil and the ionosphere has practical implications as well. For instance, this principle is used in technologies like plasma televisions and neon lights. The same ionization process that creates the captivating display in the ionosphere is used to illuminate the pixels on a plasma TV screen or the tubes in a neon sign. Moreover, frequency, high-voltage currents has found applications in various fields. It's used in and even in the entertainment industry for creating dramatic lightning effects. So, the next time you see a Tesla coil and an ionosphere in action, remember, it's not just an awe-inspiring spectacle. It's a demonstration of the power and versatility of electricity, a testament to the genius of invention. Creating a symphony of light and color. And remember, this isn't just a spectacle for you. Principles of electricity and ionization. It's a reminder that the world around us is filled with phenomena that are both fascinating and functional. So the dazzling display of lightning you see is not just magic, it's pure science. So, we've taken quite a journey through the world of Tesla coils and ionospheres. As we commenced our voyage into the realm of electricity, we unraveled the enigma that surrounds it. We discovered how, like a magician, it can transform our lives, powering our homes, gadgets, and much more. It's invisible, yet omnipresent, silently weaving its magic around us. Our journey took us to the heart of the Tesla coil, a remarkable invention by the ingenious Nikola Tesla. We delved into its workings, understanding how it uses resonance to produce high-frequency alternating currents. We learned that this seemingly simple device, with its primary and secondary coils, is a powerhouse of electrical energy. The Tesla coil, we discovered, is more than just a scientific curiosity. It's a testament to human ingenuity and the limitless potential of electricity. The plot thickened as we ventured into the realm of the ionosphere. This fascinating phenomenon where ionized gases form an electrified sphere around the Tesla coil captivated our attention. We learned how the ionosphere harnesses the power of the Tesla coil, creating a spectacular light show that's not just visually stunning, but also a vivid demonstration of electrical energy in action. When we brought the Tesla coil and the ionosphere together, a symphony of electricity unfolded before us. We saw how they interact to create a dazzling display of electrical energy, and how this interaction can potentially generate free electricity. This electrifying performance served as a powerful reminder of the untapped potential of these scientific marvels. As we reach the end of this journey, let's take a moment to appreciate the brilliance of Nikola Tesla, the man behind the Tesla coil. His innovative spirit continues to inspire us, pushing the boundaries of what we know and understand about electricity. Remember, every flash of light in the ionosphere is a testament to the genius of Nikola Tesla and the fascinating world of electricity.